Okay, this is geometry, a review for lessons 4 and 5 from chapter 11 on sine, cosine, tangent. Remember, SOHCAHTOA. The SO is the sine of any angle equals the length of the opposite side over the length of the hypotenuse. The cosine of any angle equals the length of the adjacent side over the length of the hypotenuse. The tangent of any angle equals the length of the opposite side over the adjacent side. We use these trig ratios with right triangles. So, if I had a triangle, A, B, C, and it was 3, 4, 5, the sine of angle A is the opposite side. That's opposite, 4, over the hypotenuse, 5. The cosine of angle A is going to be the length of the adjacent side over the hypotenuse. The tangent of angle A is the length of the opposite side over the adjacent side. All right, so you're not going to see that 90-degree angle. We're not going to ask what's the sine of C, what's the cosine of C, what's the tangent of that 90-degree angle. We're not going to see that in problems, all right? Now we can use these trig ratios to either solve for an angle or solve for the length of a side. All right, so we have this 3, 4, 5 triangle. We know it's Pythagorean triplet, but we don't know what the length of the degree of the angles are. So to solve for angle A, I could use this sine A. So when we're just looking at the equation, it's the sine of the angle equals the ratio. So the sine of the angle equals the ratio. When we want to solve for the angle, that's when we do the inverse operation. With inverse functions, you swap your x and your y values. So if I were to say the sine of x degrees equals y, let's just use x and y's here, then an inverse operation, that -1 indicates I'm using the inverse operation. We swap our y's and our x. All right, so we're gonna solve for this angle A. All right, so we're gonna do the inverse operations. I'm gonna swap those two values. So the sine inverse of 4 over 5 is going to equal our angle. So you do shift sine, 4 divided by 5, 4 divided by 5, and that's your angle, 53.13. All right, so 53.13 degrees. Now let's solve for angle B, because the sum of A and B should be 90. We might be a decimal off or so, but let's look at the tan of B. The tan is opposite over adjacent, so it's 3 over 4. If I'm solving for that angle, I'm going to use the inverse operation. So I'm going to do inverse tan of the ratio is going to give us that angle. So you do shift tan, 3 divided by 4, and you get the angle. It's 36.87. 36.87 degrees. All right, so you can use inverse operations to solve for the angle. Now, what if I want to solve for a missing part? I'm going to work through 4 of these. You have to see what parts you have. right, so if I have this triangle, all right, I know I have the 41-degree angle. I'm only using the parts that are given. There's my right triangle. That is the opposite. This is the adjacent, so it tells me what I'm going to use, the tangent, because I have the opposite and the adjacent sides. So the tan of 41 degrees equals opposite over adjacent. Okay, now, this is when I told you swapping your extremes was going to be a deal. We can swap our extremes. This is as though it is over 1. Anything over 1 is just itself. I can swap these two values by moving the x over here and putting the tan of 41 degrees over here, so that the value of x is 4 divided by the tan of 41. So it's 4.6. X is 4.6. Okay, let's go back to this original equation. Tan of 41 degrees is 4 over x. I could just solve it algebraically, eliminating the denominator by multiplying both sides by x, so that I have x times the tan of 41 degrees equals 4. I want to solve for x, so then I divide by the tan of 41 degrees on both sides. Remember, this is like one value. You don't separate the word tan from the 41 degrees. So this eliminates, and we have x is 4 over the tan of 41 degrees. So swap your extremes. All right, let's work another one. What if this is the triangle? And I have 57 degrees, and this is 10.8, and I'm solving for that. Okay, we look at the angle that is given, 57 degrees. The 10.8 is the opposite side, and x is the hypotenuse. What trig ratio uses opposite and hypotenuse? The sine. So that's what I'm going to do. The sine of 57 degrees equals the opposite over the hypotenuse. I'm going to swap my extremes, so that x equals 10.8 over the sine of 57 degrees. And I can put that in my calculator. Just like that. And it gives you the value of x, 12.88. All right, let's do 2 more. I just wrote in my book. We have this angle, there's a variable, 10.3. All right, what do I have? I have the opposite, and this is the hypotenuse, always opposite the 90-degree angle. If I have the opposite and the hypotenuse, I'm using sine. So I'm going to say the sine of 37 degrees equals opposite over hypotenuse. Now my x is in the numerator. I'm not going to swap my extremes because that doesn't move x. It's x divided by a value. To isolate x, I do the inverse operation of division and multiply by 10.3 on both sides. That eliminates that denominator. So x is 10.3 times the sine of 37. $6.2. right, we're gonna do one more. Maybe two more, actually. Another one where we solve the angle. All right, so 16. It's not, you don't even know which one it is. Never mind. I'm telling myself 16. Okay, that's what it looks like. We have this angle. X is the adjacent side, and 3 is the hypotenuse. Which trig ratio uses adjacent and hypotenuse? It's the cosine. That's what I'm using. The cosine of 47 degrees equals adjacent over hypotenuse. My x is not in the denominator. X is divided by something. I want to solve for x and have it be all by itself. So I multiply. Do the inverse operation on both sides. The value of x is 3 times the cosine of 47 degrees. And it gives that to you. All right, now let's solve for an angle. What if I had this and I want to solve for that angle? Well, I look at the angle. What side is this? It's the adjacent side. And what side is this? It's the hypotenuse. So I'm going to use the cosine because that's the sides that I have in relation to the angle that I'm solving for. So the cosine of theta is going to equal the adjacent over the hypotenuse. When I solve for the angle, that's when I swap my x and my y values, and I use inverse operations. I swap the angle and the ratio. So we do inverse of that ratio is going to equal the angle. So shift cosine, 5 divided by 13, and you get the angle. All right.